Hello everyone, welcome to 8.9 Taylor Series. What is a Taylor series and why do we do it? Well, a Taylor series is a polynomial which approximates a much more complicated function in a smaller area. So why do we want a polynomial? Because polynomials are easy to work with. It's a lot easier to take the derivative of x cubed, x squared, x to the fourth than it is to take the derivative of sine, tangent, natural log, and ugly functions like that. Since it's a series, it could have an infinite number of terms. However, we're only going to use a finite number of terms. More terms means a closer approximation. This is how they used to do approximations for functions before they had graphing calculators that could tell you what the natural log of 13 was. A Maclaurin series is a type of Taylor series that's around the point 0. So, the sooner you memorize this, the better it'll be. But it's really easy. F of 0, f prime of 0 over 1, f double prime of 0 over 2 factorial, f triple prime of 0 over 3 factorial, f4 prime of 0 over 4 factorial, and don't forget your x squared, x to the third, x to the fourth. What if it's not 0? What if it's moved left or right? Then do your normal transformations, x minus x. Okay? All of these are Taylor series, but a Maclaurin series is a Taylor series around 0. So if they say Taylor series at 0, it's the same as a Maclaurin series. If they just say Maclaurin series, it's a Taylor series at 0. All you're going to do is write something in this form. By the way, this is called a 5-term, 4th degree Taylor series. Find the 4th degree Taylor polynomial for cosine of x. Well, if I need a 4th degree polynomial, that means I need to go out to the 4th derivative. And I want it to be at x equals 0. I should have said that. So I need y prime, y double prime, y triple prime, and y4 prime. So, cosine is the original, negative sine, negative cosine, sine, cosine. Those are just the 4 derivatives. So now, how do I find what x of 0 is? I plug those 4 derivatives in. Cosine of 0 is 1. Negative sine of 0 is 0. Negative cosine of 0 is negative 1. Sine of 0 is 0. Cosine of 0 is 1. So I have all that I need. Now the formula says to do f of 0 plus f prime of 0 x plus f double prime of 0 over 2 factorial x squared plus f triple prime of 0 over 3 factorial x cubed plus f4 prime of 0 over 4 factorial x to the fourth. Just plug in what you know. What's f of 0? 1. What's f prime of 0? 0. What's f double prime of 0? Negative 1. What's f triple prime of 0? 0. What's f4 prime of 0? 1. And please clean that up a little bit. 1 minus 1/2 x squared, 0 plus 4 factorial means 4 times 3 times 2 times 1, 12, 24, x to the fourth. Now what they're saying is that this, 1/24th, not 24. 1/24th. What they're saying is that this polynomial is a very, very close approximation of cosine of x when you're really close to 0. Now, why would I want to do this? Because this polynomial is much, much easier to work with than cosine. Think about how easy the derivative of this would be for a calculator. Just take it down, take it down. It's easy to take a derivative, it's easy to take an integral. So before graphing calculators came along, this is how people did very complicated equations like cosine, sine, e to the x, and things like that. A third order Taylor polynomial of y equals e to the x at x equals 2. So third order means I need 3 derivatives. Luckily, e to the x is always going to be e to the x, so that's not too bad. So let's start off. I need f of 2 plus f prime of 2 x minus 2 plus f double prime of 2 x minus 2 squared over 2 factorial plus f triple prime of 2 x minus 2 quantity cubed over 3 factorial. Let's fill in what I know. F of 2, e squared, plus f prime of 2, e squared, x minus 2. This one's very easy because they're all e squared for derivatives. Plus f double prime of 2, e squared over 2 factorial is 2, x minus 2 squared, plus f triple prime of 2 is still e squared over 3 factorial is 6, x minus 2 cubed. So that is a third order Taylor polynomial, centered not at 0 this time, but at 2, because everything shifted right 2. And that does it for Taylor polynomials. It's just a pattern to follow, but you have to memorize it because they ask these questions on the AP test and on my tests. You have to know what the formula is. It's not a hard formula to memorize, but you have to know it. If you have any questions, come talk to me. Thanks.